Hi there, and welcome back. Today we will be learning about shifting a function left or right. Function transformations are not new to us. Similar to polynomial transformations, function transformations shift functions around a coordinate plane. We can also reflect and stretch or compress functions. There's so much that we can do to functions to create new functions. It may be helpful to review parent functions before we dive into this lesson. Here are some common parent functions. You will see a linear function, a quadratic function, a cubic function, a quartic function, and a quintic function. You will also notice the sine function. In this lesson, we will learn about the horizontal transformation, which will shift these functions left and right. We have seen this before when we talked about polynomial transformations. In this instance, however, we are specifically talking about functions. A horizontal transformation will move a function left and right. We can also cause this type of transformation a horizontal translation. We are typically given a number of units that we are translating the function. The shape of the graph will stay the same. We have a standard equation or formula for horizontal translations. G of x is the new transformed function. So this is the function after the horizontal translation. F of x is the original function. K is the number of units we are horizontally translating the function. In other words, we can shift f of x by k units horizontally. But that raises the question, how do we know if we are shifting left or right? That's a great question. If k is greater than 0, the parent or base function will shift k units to the right. If k is less than 0, the parent or base graph will shift k units to the left. Be careful with your signs. The standard equation for a horizontal function transformation has a minus sign inside of the parentheses. So when we want to shift a function to the right, k is greater than 0. So if k equals 2, we will shift the function 2 units to the right. When we plug in k equals 2 into the function translation equation, we see that g of x is equal to f of x minus 2. This is a horizontal translation to the right. When we want to shift a function to the left, k is less than 0. So if k equals -2, which is less than 0, we will shift the function 2 units to the left. When we plug in k equals -2 into the function translation equation, we see that g of x is equal to f of x plus 2. This is a horizontal translation to the left. Let's first look at a simple example, and then you can try the next one on your own. Sketch the graph y equals x squared, which I've done for you. We will then shift the function to the right by 3 units. This is what the new function looks like. We have kept the shape and the size, but we have moved the entire function over to the right by 3 units. The new function equation is y equals x minus 3 squared. K is positive 3 because the function is shifted to the right. Now you try this next example on your own. Here I have shown you the graph of the function y equals x cubed. I want you to shift this function to the left by 2 units. What do you predict it will look like? Pause and take a moment to figure that out on your own. This is what the new function would look like. The new function equation is y equals x plus 2 to the power of 3. K is -2 because the function is shifted to the left. Thank you.